Dear students, welcome back. In the previous session, we have discussed about direct current for the treatment of patients from the AC mains. Now in this session, we are going to discuss about surging. So here, surging is a process where the intensity of the current rises and falls in a rhythmic manner. Okay, that means here the currents used for the treatment of patient is modified here. Okay, by a process called surging. There is another process is also there which is used for the treatment of patient that is called as interruption. Okay, so currents used for the treatment of patients may be modified into two ways. One is interruption and surging. So interruption means the current flow starts and stops at regular intervals. Okay, that is one kind of modification of the currents. And another type is called as surging. Surging is the intensity of current rises and falls in a rhythmical manner. Okay, now in this session we are going to discuss about surging and the apparatus or the circuits which are used for surging. Okay, so first, if you see the exact definition of the surge, here the intensity of successive impulses increases gradually. Okay, each impulse reaching a peak value greater than the preceding one and then falls either suddenly or gradually. This is called as surge. What is the use of this surge means? So, to prevent the tetanic contraction and ensure relaxation of muscles. That is the main purpose. So, how this tetanic contraction is produced means, so the direct current is going to interrupt by different circuits. So that interrupted direct current will have tetanic type of contractions. So that contraction should be surged by these surgers. Okay. So how the surging can be done means, surging can be done by means of hand surgers and some electronic devices, which includes wall circuit or any modern equipment surgers. Okay. So now we are going to discuss in this session is wall surger, and I want to mention the hand surger also. So the surgers are mainly used in the Faradic and sinusoidal currents, and these currents are frequently surged when it is used in the treatment of patients. The surge direct current is sometimes may be used, okay, not always. Hand surgers. So this hand surgers means the Faradic current from a smart Bristow coil is surged by introducing and withdrawing the iron core. So we are going to see the smart Bristow coil in the protection of Faradic current. So there may be introducing and withdrawing the iron core, and any of the currents can be surged by rotating the knob of a circular rheostat. But this causes the wear and tear of these wires of the rheostat and should not be used frequently. So it should be used only when any other method is available, then only we can use the hand surgers. Okay. Apart from the Faraday coil, surging is commonly carried out by the valve circuit. Carried out by the valve circuit. So now we are going to discuss about this valve circuit. The first one, I am going to illustrate a circuit for the valve surger. This is only illustration. So the valve surger includes a principle. Okay, when a switch is open, here in the circuit we find a switch and a condenser, resistance, and this condenser is attached to the source. Okay, now, so when the switch is open, the condenser, here you can see, so the switch is a part of the circuit. Okay, and this condenser is going to charge through the resistance R. Okay, through the resistance R from the source of supply. Okay, as the circuit contains a resistance, what happens? The charging is fairly slow. The potential difference between the plates rises at first quickly. So the PD develops in between the two plates, rises first quickly, then more slowly as the potential difference developed opposes the charging current. Okay, so when the switch is closed, a circuit of low resistance is completed between the plates. Okay, so therefore the condenser discharges rapidly through this circuit and the potential difference between the plates falls suddenly. Okay, so for such a type you can find a graph how the current flows, how the surging is taking place. First there is a rapid increase of current, that is discharging, and then it suddenly falls. So like the graph, you can find such kind of waveforms. Okay, yes, so this is the working of a valve surger. So now we are going to use this triode valve instead of switch here. Okay, that becomes the valve surger circuit. So now we will see the working of this valve surger circuit. In the circuit, a triode valve replaces the switch. It is connected to the source of interrupted direct current. Okay, so then what happens here? The source of DC, that is interrupted DC, in such a way that the grid is receiving. So normally triode valve is having anode and cathode. In between them you'll have a grid, isn't it? So if you see the function of the triode valve, this triode valve acts as a switch, isn't it? So that is the same function. So here the switch is replaced by this triode valve, and now the interrupted direct current is attached to the grid. Then the grid becomes negative, the grid receives a negative charge during the periods of current flow. Okay, so it becomes negative. So that interrupted DC supplied, so this one is supplied from a multi-vibrator circuit. Okay, and when the grid of the triode valve has negative, has negative charge, the valve will not conduct current. So then what happens? the condenser charges rapidly from the source. Okay. And the charge is fairly slow, and the potential difference between the plates rises at first quickly, then more slowly, as in this preceding example. When the grid loses its negative charge, then what happens? Then the wall what happens here now? The wall becomes capable of conducting a current, and the condenser discharges across the wall. So this is a circuit of low resistance, and the discharge is rapid, so the potential difference between the condenser plates falls quickly. Thus the condenser charges during each period of flow of the interrupted DC and discharges when the current ceases. This is the thing which is going to happening. Okay. So in the next case you can see, so another triode wall is included in the circuit in which the current is surged, is flowing, and from which current is supplied to the patient. Okay, already here the current is surged up to this circuit, and this one is connected, the surged current which is surged by this wall surge circuit, which is connected to the patient circuit further. Okay, now so the condenser is connected to this in such a way that the grid becomes positive when the condenser is charged. Okay, so causing an increasing in the intensity of the current in this circuit. When the condenser discharges, the grid loses its positive charge and intensity of the current falls again. Okay, thus the current varies in the intensity as the potential difference across the condenser varies, rising gradually in intensity, then falling suddenly. This is the type of surge produced by most of the valve evaporators. So the duration of each surge is same as that of duration of flow of the interrupted direct current supplied to the first valve. Okay, the intervals between the surges equal to the intervals of the interrupted direct current. Thus, if the interrupted direct current is supplied from a multi-vibrator circuit, the duration and the frequency of the surges are controlled by the resistance in this circuit. So, this is about the wall surger circuit. Okay, in the next session we are going to discuss about Faraday current and what are the coils which produce Faraday type of current, and also the sinusoidal currents. Thank you.